So everybody can hear me okay?
Can now.
Okay, sorry about that. So you guys are all experts at this video conferencing thing. If you can mute your phones, that'd be great. At the end of the conference, there'll be some questions and answers. If you have something that comes up in the middle, I'll be pausing here and there a little bit. You can jump in. If you have questions, others are going to have questions as well. So we're targeting around 30 minutes. As I mentioned at the end, we'll just do the question and answer. So today we're going to be going over the product. It's kind of an assumption that you guys are all familiar with the product to some degree. We're going to go over some highlights of the product. We'll talk about the Kyntronics controller, a Rockwell Allen Bradley partnership that's going on, and then we'll get into some success stories at the end. So our value, so what do we bring? We, all the way from the beginning, we're involved in the application, sizing the application, trying to get the information on that's appropriate to the application itself. We have all kinds of proven tools that help us size the actuator, which helps us size the motor and drive appropriately. That's part of the all-in-one that we provide. The proven software, there's a slide on that. I'll get into that a little bit more on all the details of, yeah, it's an actuator. It goes from point A to point B, but there's a lot behind that. The accurate, flexible controls goes right along with the software that I'll be talking about in a little bit. Efficiencies, people, this is somewhat challenging to get across to some. The efficiency of the actuator itself is the most efficient actuation solution on the market. What does that mean? It means from the electrical input into the drive to the linear motion, conversion of the electrical energy to the energy the actuator is performing linearly. Compared to the electromechanical, compared to the hydraulics, this actuator is extremely efficient. What does that mean? It means that the drive is smaller, the motor is smaller. That means it's more cost effective for you. Reliability is another important factor that we bring. There's no major metal wear. We'll get into that a little bit in a few slides compared to electromechanical and other solutions out there. Flexible orientations takes advantage of the hydraulic fluid. Just the motor is connected to a pump and we're just moving fluid back and forth. It's surprising how many applications we're trying to fit in our actuator when they say, hey, if you can move this actuator a little bit this way, move the cylinder that way, can you do a right angle? This is electromechanical, the answer is no. With hydraulics, it's just fluid. It's amazing, as I mentioned, that how many just applications we've been able to do that just to fit into their machine so the machine manufacturer does not have to do any major modifications. So again, that's the advantage of the fluid itself. Yeah, as I mentioned earlier, the software itself, the actuator, it's just a linear actuator. It goes in and out. There's a lot behind that. So this actuator has position control and force control all built in. Force equals area times PSI. We have a pressure sensor, so we can do quite a bit with this actuator. Position control. Position with force limiting, so you're coming down, for example, on a press, you hit something that the pressure's monitoring. You kind of want to make sure you don't exceed a certain force placed onto the product for a certain amount of time. It can retract a little bit. All kinds of different moves, different profiles can be chained together with this proven software. Today we have the software has been developed over many months / years, and we're applying the software as a standard to each and every application. Multiple gain sets. Doesn't sound like much, but we need a certain gain set on the extend and a certain gain set on retract just to be able to make sure we're positioning and applying force accurately. coordinated motion, actuator to actuator, make sure they're coordinated together through field bus, compound moves going to a certain point and changing speeds at another point. Also the GUI development we can do, and diagnostics and field bus and all those features that are built into the actuator itself as a standard product. A lot of you are familiar with the competitive technologies out there, the electromechanical actuators and the HPUs, hydraulic power units. Just wanted to point out some of these challenges. Gears, roller, bearings, and ball screws, they're complex. They all have metal to metal. They all have challenges regarding life. They all have a definitive life. IP challenge as well, and regarding the environmental IP65. We're IP65 out of the gate. We've got to make sure none of our fluid can get out and no contamination can get in. We easily do IP67 and IP68. We're doing IP69K as well. So our actuators are very environmentally focused actuator. EMAs require a break the hole position. All we use is a check valve. Preload and various things you're familiar with to get accurate positioning. We don't need any of that. As you get above 5,000 pound force, 6,000 pound force, those graphs really diverge regarding the cost. The costs get very expensive for EMAs. HPUs, the pumps run continuously. They're oversized, they're noisy. Of course, all the environmental headaches that go along with that, maintenance and contamination issues. Floor space is a big thing. The HPUs and all the hydraulic hoses take up a lot of room. There's dollars associated with that. A lot of HPUs are sized to run a finite amount of cylinders. If you have 10 cylinders, maybe they can only run 5 or 6. Ours all can run individually as many as needed. It's always difficult to upgrade the HPU, add another cylinder, coordinate more than 5. It's also costly to do coordinated motion and accurate control. Very challenging to connect up field bus to solenoids and pressure sensors, and they're all over the place throughout the machine. All these challenges are solved with the SHA. I won't get into all these details here, but you can see how the SHA solves each and every one of those challenges on the prior slide. Power on demand. As soon as you need power, it runs. As soon as you don't, it stops. The all-in-one solution. Just a few words, but there's a lot that goes into that. As I mentioned earlier, it's the front end. A lot of work goes into making sure the application is sized appropriate, the motor, the cylinder, the pump, the drive, etc. Once that's all determined, we source the products, the parts, put the actuator together, assemble it, and we test it all here to the application's needs. If it's a certain force, we try to tune the actuator to that particular force. Again, it's all 4-quadrant control, force, position, etc. So when a unit ships out of here, it is tuned to the best of our ability to your needs, all set up. All you need to do is connect it up to the machine. Of course, there's going to be possibly some fine-tuning in the field as needed on the machine specifically itself. We're always looking to improve. So based on the voice of the customer, based on the field feedback, we're always looking to improve. Today, no painted surfaces. We updated our couplings to a more robust solution to avoid any side loading on the pump and axial loading. I mentioned the software being standard. What does that mean? It means we can easily set it up here. We can easily debug in the field as needed. The same software is being used over and over again. We updated our linear feedback to make that more robust, solid. We're getting into more and more higher accurate requirements. We had to make that a little more robust when we were talking tenths. Assembly, of course, we're always looking to improve our assembly, manifold design, thermal enhancements. We're updating our valves for better performance, as well as integrating the counterbalance valve designs for various applications. The controller, what does this mean? Kyntronics, as we launched the SHA, we're looking out there for a lot of off-the-shelf controllers. Some controllers have various pieces, but nobody has everything that we need for the SHA itself. Multiple gain sets, 12-bit inputs for 0 to 10 volts is what people have. We need 16-bit. We need all these different bandwidth capabilities, higher bandwidth. So we went out and we invested in building our own controller. So this is significant. Those of you that understand motion control, we're doing everything. We're building the board, we're controlling the FETs, we're controlling everything from one end to the other. So you can see the controllers, the brains, the VeKtor program, the PC interface connects to the controller. The power boards are several different sizes. The power boards are really basically the same design, just the components, capacitors, and various components are scaled up or down. The DC is down the road a little bit. Today we're building this guy right here, the 240 volt, 40 to 60 amp power board, which connects to the controller. So the controller's the brains, it can connect to any one of these power boards. You can see the various phases here. Today we're in phase 1. We're already controlling things. We already have some beta sites out there working. Sales demos, every sales demo in the future will have our Kyntronics solution, hardware and software. Our goal is to make this as simple as possible for the user to set up various profiles. You can string these guys together. I won't get into too much detail on that, but again, our goal is to make this very simple. So the edict to the development team is keep it simple. Oscilloscope functionality. So some of the highlights for the sales demo kits that will be going out. New orders, again, will all include the Kyntronics total solution. All the modes will be able to be demoed: force control, force with position limit, position with force limit, various profiles, compound moves, etc. So we partnered with Allen Bradley. Allen Bradley approached us and we talked to them. We went back and forth a little bit. We had several projects out there that were somewhat challenged to get our system working ideally and optimally. Again, that multiple gain set thing, having the 0 to 10 volt for feedbacks and various other things. So there's several Allen Bradley projects and they're successful. But what we're looking to do is to partner with Allen Bradley to provide ladder-based blocks that include all of our proven software that we've talked about, that I talked about previously, with all our controls implemented into the all the product line of the Rockwell. So we partnered with Rockwell. They provided hardware and software to us. We provided our actuator. You can see the development action on that picture there. It's a little bit messy, but that's R&D. So we made a lot of progress so far. Right now, we're looking around on a Q3 release. We're having weekly meetings with Rockwell. This is a big focus for them, and we're looking to get this launched out there. There's a lot of installed Rockwell plants that demand that, and they would love the Kyntronics solution to go along with that. So this is designed to make it easy for the integrator, customer to support and develop the software. This is an example of the a tier 1 auto manufacturer, 16 actuators. You see the mess on the left-hand side with all the hoses and solenoids, and we're all familiar with that. So this is an Allen Bradley solution. It freed up about 50% space, productivity went up, increased quality, increased the accuracy, and a much cleaner environment. One thing to point out is we replace a lot of hydraulics out there, and a lot of times we're very competitive, if not more cost effective than a HPU. In some instances we're not, and that's just cost versus components versus the actuator cost. A lot of these other parts are somewhat forgotten. How much is space, what's that worth to a customer? How much is it worth when productivity is increased, your quality is increased? Those are all just things that to think of when we're quoting head-to-head with somebody, and it comes down to cost. We'll get into some of these applications. Successful applications mentioned, we've replaced a lot of hydraulic units out there. A lot of end customers are demanding no hydraulic infrastructures, want to eliminate it all. What other solutions are out there? You have electro-mechanical and you have the SHA. Well, electro-mechanical actuators have made good inroads into the hydraulic market. They were focused on it for quite some time. Well, a lot of customers are finding that those electromechanical actuators are failing. Hydraulics is a much more reliable solution. Obviously with the mechanical wear, for example, if you're a press, you're coming down, you're pressing, let's say, 10,000 pound force on the last 1 inch of travel. All that mechanics is seeing that 1 inch over and over and over again at 10,000 pounds. You get that wear and you have premature failure. Presses and clamping is a very popular industry for us, as well as testing. Just some of the press examples out there that we've done, from small to large presses, all kinds of different industries, automotive, appliance, assembly, metal forming, and several others. Most of these presses perform position and force control coming down, and you can switch between positioning and force control on the fly. You don't have to stop with our program. It's all set up to be seamless. Very versatile control capabilities compared to the hydraulics. You can just connect up the field bus, get diagnostics as needed. Obviously, there's no hoses, no leaks, much more efficient. This next example is a 4-axis coordinated lift solution. You may have seen the video that was sent out by our sales team. Synchronized platform lift. This was a construction site for mass climbing. Places the rack and pinion, increasing their payload. An IP67 rated solution. The motor's enclosed. So in this example, it goes from, if you're locked in P2, you're lifting up the platform to P4. The P4 pins will be locked. P2 pins will be unlocked. It then lifts up the bottom platform up to P3, then lock and goes up to P5. So it keeps on crawling up the mast. Field bus communications. This particular application used our controller and our software. This is using our canned lifting program, out of tolerance monitoring, so it's looking at other actuators. Each node monitors other actuators and adjusts as necessary, uses a virtual master broadcasting target reference. It's all load independent and speed independent. What does that mean? It means if there's a load, an extra load on one actuator, the actuator is just going to do what it needs to do to maintain that position. So the load does not have to be in the center. It could be offset in any manner. It's independent of speed, so as slow as you go or as fast as you go, it's all going to be synced together, again, through the field bus connectivity. It's interesting how many applications that require our actuator regarding the testing industry. Majority, if not all, of our testing applications are replacing HPUs out there. What does that provide them? It provides them a versatile control. They can take this actuator and move it from one test to another. Field bus connectivity to their lab view or the PC or their PLC gives them that diagnostics and data collection that they need. Very simple solution that's versatile. Just some of the customers listed there, and customers. This is an example we sold to one customer, 2 actuators. They needed this in their lab. They wanted a 3,000-pound actuator and an 8,000-pound actuator. They can configure in either one of these in all kinds of different configurations. Independent, so they can have the 3,000-pound actuator doing force position control on whatever they want to test. They can do the same with the 8,000. They can set it up to be force or position. They can connect these things together, either pull material or push material. And this GUI is our GUI. We provided them an easy-to-use setup so they can configure the actuators in any mode they want. They can move these actuators all around their shop to perform all kinds of different tests as needed. This application is a testing application regarding a C-frame test. They wanted an actuator to test multiple C-frames. They preferred a load cell on the end. So we implemented a load cell, brought the load cell into our system, closed the loop with that, tuned appropriately. They want to do frequency fatigue testing on these various C-frames. Of course, we're connected through field bus to their PLC, providing diagnostics. They can easily set up the amplitude, set up various set points and targets as needed through the field bus. So in summary, same thing that we already mentioned, application up front, application sizing, proven tools to optimize your solution, the all-in-one solution that we provide, versatile, accurate control. As I mentioned earlier, we can get into the tents as needed with certain repeatability requirements. Very efficient actuation solution out there that leads to cost-effective, very reliable, and flexible orientations. So it was quick. Now I'm open to any questions you have. Thoughts? Anything?
Hey, Carl, can you hear me okay?
Yes, sir.
Okay. I didn't know if you were muted or not. I was just going to say, if any of the guys out there, this is Jeff Miller, if any of the guys out there had questions that they wanted to ask me offline, please feel free to reach out to me. I'll certainly respond immediately. And before you all start jumping off, I want to say thank you very much for taking the time out of your busy days to join us. And hopefully this was helpful and beneficial. We hope to do these, maybe put together one a month with all of our new advancements and all of our new product developments, and keep everybody abreast of how we're constantly in a state of improvement here at Kyntronics. Thanks again.
Okay, I'm going to try to answer some of these questions that are on here. So from Rob, is Kyntronics looking to become an Encompass partner? We are. We're looking to do that. We'd like to get this AOI done first, and then we'll go down that road. From Gordon, will Kyntronics be providing support to go along with that? Yes. That was one of the reasons why we wanted to develop the software ourselves, so we can provide that support. We can be the front line. Alan Bradley will not be able to provide the support that we can provide.
Hey, Carl, this is Gordon.
Yeah.
Hey, thanks for taking my question. So, I mean, obviously in the past we've tried to do the synchronized Rockwell motors. Are you guys addressing that as well?
We are. Yes, I meant to say that, and I didn't. Thank you for bringing that up. Yes, we're going to be doing that. Exactly. Yes, and as I mentioned, we'll be able to support it, get into the graphs and everything.
Muted. Unmuted.
Suppliers for the motors out there. Electronics are usually outside the explosion-proof world, and the actuator itself it comes down to the connectors and the motor. So yes, we can provide that.
Is the plan to provide two solutions for controls, all Kyntronics with options for field bus, or all Rockwell, including the Rockwell motor?
Yes, and then we'll also provide other. So today we're providing a couple different solutions, control techniques as well as AMC. Our software is developed in Codesys on the CT drive, and that's portable into our world. So we'll have our world once it gets out there, and the Rockwell solution is another solution.
Thank you all for attending.
So it said Rockwell across the board, but is it Rockwell Control Logics right now? Because in that Compact Logics and then the Micro Logics isn't really the same platform and doesn't really support full-blown Ethernet IP.
Right. So the goal is across the board with Rockwell, and of course it needs to be applicable to the actuator, the motor, and the complexity of the application or lack of complexity. So it's supposed to go into the ladder logic, which is supposed to go across their product line. And once we get this more defined, we can give you more details on that.
They're going to build a block, I'm assuming.
Right.
Well, then my bigger concern isn't so much, some people are going to want Rockwell, but the Kyntronics solution. So what kind of support is there around the country and the world for the Kyntronics control system?
Yeah, once we launch that, the Kyntronics solution, which I may have not mentioned, is targeted for Q4 this year. Once we get that out, we'll support it just like we're supporting everything else out there today. Anyway, so if you can hear me, the plan is just like we're doing. We're going to have multiple tiers. You can support through the phone. You can support through what we're doing today is Team Viewer as needed.
And some more items. For more info on using RMC
or on site.
On our
yeah, I know.
Okay. All right. I appreciate the update, guys. I'll take up my questions specifically to Mike so that we can have a further conversation on it. Okay? Great job, guys. I appreciate it. This is Bob Yeager at GCC. Okay.
Thanks, Jeff. Appreciate it.
Differential pressure.
Another question came from Greg for vertical hanging load.
Because we just multiplied the area.
Is a rod lock required, or is there another way of getting feedback for safety? Yeah, we've done a couple different things on this. For vertical hanging load, if I understand this properly, we can implement a separate solenoid for safety purposes.
pressure.
We've done that before.
Unmuted.
Another question came from, can you connect to any one servo? The answer generically is yes. We can, as needed when it makes sense. Bob also asked about the field bus. Yes, we'll be able to do Ethernet IP with the Kyntronics solution. Somebody needs a mute. We finally got that done. Okay, anything else? Any other questions? Very good interaction. You guys have anything, feel free to email me, call me. I'll be more than happy to answer, or as well as our sales guys. Nothing else, we'll sign off. Appreciate your time.
Thanks, Carl.
Thanks, guys.